This is a recording for Notes for Geometry, section 2.9, and it's called Proving Lines Parallel. The essential question is, can you prove lines parallel using angle relationships? So if you remember in the last lesson, at the end, the multiple choice reviewed kind of those angle pairs when lines are parallel. One of the reasons we did that is, well, to review after our break, but also because now we're going to say, okay, the converse might be true as well. And that is that if an angle pair has a relationship of either being congruent or supplementary, then the lines will be parallel. That are used with a transversal. So again, this is 2.9, proving lines parallel. Can you prove lines parallel using angle relationships? Make sure you've written your level of understanding. There is no key terms page, but you should find this handout with some postulates and theorems on it, and then the one with problems on it, and then we'll also be doing quite a bit of multiple choice again, because we're trying to review things as we go. So the first thing we're going to do is just go over these postulates and things like that, ways that we're going to write them, and we do need to know these as we move on into the next chapter. So this first one is called the converse of the corresponding angles postulate. First, I'll read it. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. And I'm going to really highlight specific parts. If CORR for corresponding angles congruent, then lines parallel. And we're going to call this the CORR angles postulate converse. And I'm trying to write the word converse kind of big because we want to know for sure that this is the converse. The next one is called the parallel postulate. We use that a little less in this section. If given a line and a point not on a line, then there exists exactly one line through the point that is parallel to the given line. So the power in that one is that it allows us to say, okay, if we find a parallel line, it's the only parallel line. So if given a line and point not on the line, then exactly one line through the point is parallel to the given line. So that one we just want to kind of know as we go. Then the rest of these relationships are called theorems because we have that correlate or postulate that we're going to assume is true, and then these we can kind of get from that. This is the alternate interior angles converse, and so I'm going to abbreviate it ALT, EXT, angle S converse. And it says if two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then the two lines are parallel. So we're going to do if, and of course it is important that they're in the plane and there's a transversal, but we're not going to underline all that. We're just going to say if ALT, EXT, angles congruent, then lines parallel. So that's going to be kind of our quick way of doing that. Also, you'll notice it kind of gives a nice little short version of it right there as well. Oh, I'm going to back up a minute. I'm going to just have you mark a pair of corresponding angles congruent. We'll say 1 and 3 on that first one. And I did forget to do that, so do that if you need to. Pause this if you have to. And then sliding down here, mark these alternate exterior angles, angle 1 and angle 3 is congruent as well. The next theorem is the consecutive interior angles converse, and we're going to name that consec, C-O-N-S-E-C, INT, angle S converse. And this one, though, the angles aren't the same measure, they're supplementary. So if two lines in a plane are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the lines are parallel. So if consec int angles supplementary, I'm going to underline that whole word, then lines are parallel. And so for this one, really underline or highlight that the measure of angle 4 plus the measure of angle 5 equals 180. So that's what we have to get there, is that those alternate or consecutive interior angles are supplementary, so they're not equal to each other. The next one is the alternate interior angles converse. And so we're going to call it the ALT, INT, angle S converse. And that says if two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. So if ALT, INT angles congruent, then lines parallel. And let's mark angle 6 and angle 8 as congruent as well. And then our last one here is the perpendicular transversal converse. And it says in a plane, if two lines are perpendicular to the same line, then they are parallel. This one's hard for me to make smaller. So if two lines perpendicular to same line, then parallel. So that's as good as I can get for that one. Now, you might want to take some time and review the angle pair names and relationships from, I think it was, section 2.7. I could be wrong there, but I'm just going by memory and I don't have those notes with me right now. But we'll just say that's what it is, or around there. Now we're going to move on to our problems. And so essentially, if we can name the angles and we can find the relationship on this handout, that handout, then we'll kind of know what we need. So it says given angle 1 is congruent to angle 3. Let's mark those as congruent. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. Also, I'm just going to tell you that if there is a pair, you have to say which pair, because like, it could be A and B, A and C, B and C. So we have to know which angles they are. And if we think about that, if you trace angle 3 and angle 1 and then extend them, look, these are going to be the lines that might be parallel, would be A and B if there's a relationship there, and the transversal goes right there. So always think about tracing that in your head or on paper as we go. So let's write down some notes. First of all, can you identify angle 1 and angle 3? They are, ready? Corresponding angles. Angle 1 and angle 3 are corresponding CORR angles. And we know by, that means that angle 1, and we know angle 1 is congruent to angle 3. And so we can say the two lines are parallel. The lines are A is parallel to B. And the reason is, and by the way, if you can name it, you can say it. The name is the corresponding angles postulate converse. So if you're ending with the angles being parallel, you want to say, oh, that's a converse as we go through this. So let's try another one. The measure of angle 1 is 103. So I'll just write it in there. The measure of angle 4 is 100. Is it possible to prove that lines are parallel? So this is a different situation than before. Think about where angle A is, it's that one. Think about where angle 4 is, it's that one. So if we extend those, A would be there, C is there, and this. So the lines we're talking about are angle or line A and C. Notice we just don't know anything about B, so we can ignore that. So look at those two angles. They're both in the tunnel, so they're interior angles. They're on opposite sides of the transversal. Can you name them? And the name is, they are alternate interior angles. Angle 1 and angle 4 are ALT, INT angles, but they are not congruent. So I'm going to say it this way, angle 1 congruent not is not congruent to angle 4. And so line A is not parallel to C. And that's really also by the alternate interior angles converse. In this section, it's converses. Be careful because on the test, we'll be doing both sections that we've had here. Okay, moving on. Now we want to find the measure of angle ZYN so that line PQ is parallel to line MN and identify the postulate or theorem that we're going to use. So take a minute, write on your handout, trace the angle ZYN. So here's Z, Y, and N. It's this one right here. And we want these two lines to be parallel, so make a little parallel mark. And look, we have this other angle here. And can you identify and name these two angles here? Angle ZYN, angle ZYN, and angle, because that's the other one with an algebra expression, PXW, angle PXW. Are, fill in the blank. What are they? Well, here's the tunnel. They're outside of the tunnel, so they're exterior angles. And here's the transversal. This one's on this side, this one's on that side, so they are alternate exterior angles. So those are alternate ALT, EXT, angles. And we have the postulate or theorem that we're going to use. If those are alternate exterior angles and we want to make the lines parallel, then they are congruent. And so we're going to be using the ALT, EXT angles converse. And by that, the measure of angle ZYN is equal to the measure of angle PXW. Now, go ahead and pause this and try to put in the algebra expressions and solve for X, and then we'll check and see if we're right. And then we'll put it back in to see what that is. So let's see how we did here. So we know that those two angles are the same. And so I substitute in my algebra. I'm going to get the x's on the same side. And there's really 4 steps that would be correct at this moment. I always like to get the x's on one side. It just makes me feel happy to do it that way. And so I'm going to subtract 7x. Then 35 is equal to 4x plus 20 minus 25. I'm going to add 25 to each side. 60 is equal to 4x. I'm going to divide by 4 on each side. And then 15 is equal to x. So did you get 15 for x? Awesome if you did. And so we know that x is 15, but in the problem, we're asked and I'm going to slide this up so I'll have to remember, we're asked to find the measure of angle ZYN. So a reminder, the measure of angle ZYN is equal to 7x plus 35. And so to find that, we're going to take 7 times 15 plus 35. And when we do that, 7 times 15 is Let's do 15 times 7. I don't have a calculator handy. And that's 105. So 105 plus 35, and that is 140. 140. And so that is how we can find that one as we go. Then our last one here is just a question about, how could you figure this out? So in the window shown, the diamond grid pattern is constructed by hand. Is it possible to ensure that the wood pieces that run the same direction are parallel? Just FYI, construction, home projects, lots of things use geometry and parallel and perpendicular lines and things like that, and these angle relationships. Even if a person can't name them, sometimes they kind of can intuitively figure them out to help them build something. So is it possible to ensure that the wood pieces that run the same direction are parallel? And if so, explain how. If not, explain why not. So if I kind of think about these, and I'll just pick a few of them right there, and if I think of that as my transversal, notice if I have that angle, that angle, that angle, that angle, and if I can keep going there, that angle. If those angles are all the same, those would be corresponding angles. And we could do likewise with other parts of this as well. And so we're going to say yes. And we could do the same with the other directions of lines. The lines are parallel, and it's by the corresponding angles postulate converse. We have to remember that the word is converse there as we go. So the next thing you're going to do is the multiple choice here, and I'm going to have you do those today, and then we'll check them tomorrow. So I'll put them on this PDF. Okay, so moving on in your notes, this is going to be the multiple choice for 2-9, and it includes 2-9 and 2-8. And I'm going to show you the multiple choice now, and you'll do those, and then we'll check them in the next recording. So here are the multiple choice problems. And you can see it's 1AB, 2 and 3, and then 1 through 6. The 1 through 6 are on 2.8. When you're done, you'll do your questions and summaries, for 2-9. I kind of copied this from the other file. And at the end of the lesson, you'll put your level of understanding. So here's number 1. Given that angle 1 and is congruent to angle 5, is it possible to prove that any of the lines shown are parallel? And yes, which ones, or no, not possible. So moving along, here's the next one, 1B. Pause it if you want to answer that, or you pause it to answer that. Moving on, here's number 2. Pause it to answer this one. Moving on, here's number 3. Pause it to answer this one. Moving on, now this is the review about slope. So here's number 1. Pause this to do that one. Moving on, here's number 2. Pause that to do number 2. Moving on, here's number 3. And pause that. Moving on, here's number 4. Pause it to do number 4. Moving on, here's number 5. Pause it to do number 5. Moving on, here's number 6. Pause it to do number 6. Number 6 is the last one. So take some time, write your questions and summary, and maybe something about the converse, maybe a question, something that's going to help jog your memory as you do these problems, and just kind of see what happens there as we go. Then in the next part, we will look at how these worked out. Have a great rest of your day.